Hi, this is our pre-lab video on woolly worms where we are going to look at the question, does coloration play a role in the selection of woolly worms? The topic that we're going to be focusing on is adaptations. So we're in this unit 2 on biodiversity. And we've already established the benefit of having these different levels of biodiversity, genetic, species, and ecosystem diversity. So in this activity, we're really focusing on the value and importance of genetic biodiversity or genetic diversity within a species. We're going to dig into 3 science practices. This will be the activity that is a lead-in or will work parallel with Who is Luna's Father, and we'll add another science practice when we do that particular activity within this unit. I think you're already getting the idea that I like to do a lot of authentic data collection. It just makes that data easier for the students to grapple with and understand. And this idea that our students are in an AP Science class and we want them thinking like scientists, being scientists, doing good science. And so we're going to deal with this mathematical routines and data analysis again, and really being able to interpret the results of our activity and apply that to some broader in understanding and ultimately an environmental solution. So we're going to be doing a chi-square analysis. You don't have to worry much about understanding that before we get into our live session where we'll look at the data. And what I'm really going to focus on in that live session is how do I take this student who has never had a stats class, doesn't feel very strong about their mathematical abilities, and get them to understand this statistical method. So again, our question, does color play a role in the selection of woolly worms? We'll work with the statistical null hypothesis to analyze our data at the end. And I just want to give you a little bit of a general idea of how the lab works if you were to do it in your class. It's a great lab, and my kids really enjoy it, and it really gets the idea across. So it's a little hard to see all the colors, but I make a color-coded key for them with 8 different possible colors of woolly worms. And this is where it's really critical that the students understand that this is not 8 different species of invertebrate. This is all one species of invertebrate, a woolly worm, and there's natural genetic variability within that species. There are 8 different color variations or varieties of woolly worm, all within that same population. And I just pick an area outside the front of my school where there's some trees, there's some cement, there's some grass, there's some vegetation with mulch around it. And I don't tell the students this at the beginning, but there's 100 of each of those 8 different varieties of woolly worms. It takes a little bit to set up the area because you want to make sure all those 800 worms are randomly distributed, and there's not a lot of clumping of all of one variety in one area. And so the first few classes that I have, my first couple sections, will simply tally how many of each worm they see, and we use all that class data, obviously. And then my last class is the section that actually gets to pick up their worms. So that's all the further we're going to go for today. Go ahead and look through the lab handout if you'd like, and just to kind of get a sense of what we're going to be looking at with that data. And I'll see you in our live session.